Hey there, students. Welcome to your Chapter 6 review for your upcoming test on systems of equations. This review is going to go over all of the major keys that will be featured on the test, but I encourage you to also use the study guide you've been provided with to support your studying efforts. So really, to make sure we are best prepared for the test, we should be doing both the study guide and this video. Now, of course, in the video, you don't have to watch the whole thing if you're feeling super confident about a certain skill, but I do encourage you to at least skim through it and make sure to really focus on the things that you are not sure about, okay? So with that being said, let's dig right in. The first type of question we're going to look at is a translation. We are being given a word problem and we are translating it into a system of equations. Now you guys should be feeling really great about these because you did a great job on your projects. But a couple of reminders. When you are trying to translate into an equation, take one piece at a time. So first, I see find the value of two numbers. So I'm going to have an x and a y. Those will be my two numbers. If their sum is 9. Now we need to remember our keywords. Sum is addition. So they're telling us that the value of two numbers will have a sum of 9. So we can start by writing that. X plus y equals 9. Then it tells us that their difference is 1. Now, difference is subtraction. So this would be x minus y equals 1. So that would be our system to represent this word problem right here. Now let's do the next one. The next sentence or the next problem states the sum of two numbers is 15. So those two numbers, we're going to make x and y, or a and b, or e and f. It really is up to you to choose which variables you'd like to use, but we're going to use x and y, and they used the keyword sum again and told us that that sum would be 15. So that equation can be written as x plus y equals 15. Then it tells us that their difference is 1. So again, x minus y, difference is subtraction, equals 1. Now, let's move on to our newest topic, which is systems of inequalities. So this is the most recent skill that we have learned, but really, we realized as we were going through our lesson that it was no new information. We were just combining some of the skills we've already learned. So let's start with a question that gives us a system and then asks us to match the system to a specific graph. So we need to figure out which of these graphs represents this system of equations. So my system is y is greater than or equal to 6x plus 5, and y is less than negative 1/2 x minus 8. Now, in order to see which of these graphs correctly matches this system, we have to remember our slope-intercept formula. So remember that this is really y equals mx plus b form. So that b, that y-intercept, is where we can start. So this is going to be the easiest place to start your elimination process. We want to eliminate the graphs that could not be the correct answer. So if my first inequality is y is greater than or equal to 6x plus 5, the y-intercept is going to be 5. So I also want to notice what kind of graph it is. It is greater than or equal to, so that's going to be a closed line, a solid line. So we want a solid line that is passing through positive 5. And then we look at our slope, and our slope is a positive slope. So that means our line should be going up towards the right. So we're looking for a graph that has a solid line with a positive slope intersecting at 5 on the y-intercept. So if we look at our first graph, we notice, first of all, it's counting by 2s, 2, 4, 6, 8. And my solid line does pass through close to 5, but not close enough. And the line is going down. It's a negative slope. So if this is a negative slope for the solid line, this is not our answer. Now, if we look at the next graph, the solid line is passing through what looks to be about 1 on our number line or on our y-axis, but again, it is a negative slope. So we can cancel that or eliminate that answer out as well. Now let's move on to C. Now for C, again, we wanted a graph that had a solid line going up towards the right with a y-intercept of 5. Well, on this graph, we do have a solid line going up to the right, but this y-intercept is 8. And we want a y-intercept of 5 for the solid line. So we can eliminate that one, but we don't want to make the assumption that D is correct, just in case we made a mistake on one of these. So we want to double check our graph for option D. So again, we said we want a positive line that's solid with a y-intercept of 5. So if I look, here's 5 on my y-axis, and my positive solid line is passing through that intercept point. So this graph does match our first inequality, but it has to also match the second. So the second line, here we have a dashed line because it is an open symbol. We have a negative slope, so our line should be going downward and be dashed, and our y-intercept is -8. So we should have a line going downward that is dashed, passing through at -8. So we've confirmed that D is the correct graph that matches the system of inequalities that has been provided. All right, let's move on to the next type of question. Here they are giving us a graph of a system of inequalities, and we have to name a point within the solution. Now, this graph might look a little bit different because they only shaded the solution. They didn't shade the other pieces like we've been doing in class, but that actually makes it a little bit easier because it's clear this is the area they are referencing. So if this is our solution, we can name any point in this shaded area. So let's pick this point. That's -3, 1. That would be a point within the solution. How about up here? -1, 3. That's also within the solution. But what about over here? -1, -1. Notice how that's not within the shaded area. So that would not be within the solution of this system. So when you're being given a graph like this and asked to name a point, it can be any point within that solution, but it has to be within that shaded solution area. All right, now working a little bit backwards, here we're given a graph again, but this time they're asking us which of the following points is not in the solution. Notice the key word not. If you ever see the word not or the word all, be suspicious of those. So we want to see which of these is not in this red shaded area. The only way to do this is to graph it. All right, so when I check your papers, I should see all of the points on your graph and then clearly one of them not in the shaded area. So let's start with 1, 1. So over 1, up 1. There's our first point. So that is not the answer because it is in the shaded area. And we want the points that are not in the shaded area. 3, negative 4. Over 3, down 4. That's also within the solution. Negative 3, 4. So over 3 to the left and then down 4. Now that point, it's in between our lines, but it's not in the shaded area. So this is the point that is not in the solution graphed by the inequalities. Now to be sure, we want to check our last answer, 5, 2, over 5, up 2, and that's also within the shaded area. Okay, moving on. Now we are being asked to create the graph instead of being provided with one. So for this problem, they're asking us to solve the system by graphing. Notice, pay close attention to this, that these are inequalities. And I've seen sometimes we seem to forget that when it's an inequality, we need to have the shading on the graphs. Because a solution to a system of inequalities is not just one point. It is a group of points or an entire area of points. All right. So we remember that we need to shade, and then let's look at our two equations. So we have y is greater than or equal to negative 3x minus 2, and y is less than 2x plus 3. So I'm going to start with my first inequality. I notice that it is a solid line. It is a negative slope. And it has a y-intercept of negative 2. So that's what I was able to tell from this inequality. So to graph that, I'm going to go to negative 2. I know it's a negative slope, and my coefficient is negative 3, so that means I'm going down 3 to the right 1. Notice I've run out of space, so I'm going to go back to my y-intercept and do the complete opposite. So instead of down and to the right, I'm going to go up 3 and to the left 1. Up 3 to the left 1. Then it's time to connect the dots, and I want to make sure I do that correctly, so I double check. It is a closed symbol, so we need a solid line. So I'm going to connect those dots with a solid line. So we have our first inequality graphed. Now let's do the other one. Y is less than 2x plus 3. So this one, we are going to have a dashed line. This time it's a positive coefficient, so a positive slope. And our y-intercept is 3. So to graph that, we're going to start at positive 3. And because it's a positive line and the slope is 2, we're going to go up 2 to the right 1. Now we've run out of space, so we go back to the y-intercept and go down 2 to the left 1. 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 All right, so we have our plots, or our points plotted. Now we have to connect the dots. Remember, this one is a dashed line, so when I connect them, I am going to make sure I do so with a dashed line. All right, so now we have our two lines graphed, but it's a system of inequalities, so we have to remember the shading. So we're going to pick a test point, 0, 0. And let's plug it into each of these. So this would be 0 is greater than or equal to negative 3 times 0 minus 2. So 0 is greater than or equal to negative 2. And that is true. 0 is greater than or equal to negative 2. So that was our solid line, and it's true. So we're going to graph everything on the side of the origin point, on the side of that test point. So I'm just going to shade all of this in. I'm not going to waste your time by doing a thorough job, but I hope you do on your test. And then we have to shade the other inequality. So this one, we're going to use the same point, 0, 0. This time we're looking at the dashed line. And when we plug that in, 0 is less than 2 times 0 plus 3. 0 is less than 3. That is also true. So we would shade everything on the point or on the side of the test point, which is right here, and this is the line we're working with. So we're going to shade everything to the right of that line. Now, once I do that, I can see where my solution lies. And for this system, my solution is this area right here. The green area. That's why we like the highlighters. So it's a little more clear to see where the overlap is. So this is our solution. Now, if I asked you to pick a point within the solution, you could pick anything that is within the green in overlap. So my point could be this one, 2, 2. Now let's do one more just to make sure we're feeling good about these. So this one, we have y is greater than 5/3 x plus 3, and y is greater than negative 2. Now, for my first inequality, I have an open symbol. So this is going to be a dashed line. I have a positive coefficient, so a positive slope, and a y-intercept of positive 3. Now, the reason I'm writing this down is because this is my checklist to check my work at the end. When I am done graphing, I'm going to go back and I'm going to make sure that my graph has all 3 of these things. That way I know I didn't accidentally graph the wrong slope or intercept, which is a very common mistake that we're seeing. So that checklist can be your solution to avoiding those mistakes. So let's graph it. Y-intercept is 3, so let's start at positive 3. Slope is positive, and it's 5/3. Now, I don't have enough space to go up, even though my slope is up 5/3. So I'm going to do the opposite, down 5, 1, 2, 3, 4, 5/3. And you'll notice I've run out of space again, so I can kind of estimate just so I know my line's at the right angle. But then I'm just going to connect these 2 points. Now, for these points, I want to connect them with a dashed line. 3, 4, 5. So I'm going to connect these with the dashed line. Using a straight edge is a lot easier, so do that on your test. And then I am going to move over to the next one. Now this one is also an open inequality sign, so that's going to be another dashed line. But this time I don't have a slope. There is no x, so there is no slope for this line. And my y-intercept, that's all they've given me, and that's negative 2. So we're going to go down to negative 2. And remember, when there's no slope, that means it's a horizontal line. So we're going to draw a horizontal dashed line. Make sure to check that it is dashed when it's supposed to be. So now we have our two lines graphed. Now we pick our test point, plug it in, and decide where to shade. So 0 is greater than 0 plus 3. 0 is greater than 3. That is false. So our first line is my dashed line right here. And because it's false, that means we need to shade everything on this side of the graph, on the opposite side of the test point. Our test point was over here, but it was false. It was a false test point. Now, let's do our second line. We've graphed it. Now we plug in our test point. 0 is greater than -2. That is a true statement. So for our second line, we're going to shade everything on the side of the test point, which is above our dashed horizontal line. So all of this space is going to get shaded in. And we can see our green area of overlap is right here. That would be our solution. Okay? So that's what your answer would look like if you're all done and you did it well. You'd have all your work shown, your lines graphed clearly, your shading neat and clear. If I can't tell what the different sections are in terms of like if you're using the same pencil and they all look the same, I'm not going to be able to see if it's graphed accurately. So use this as an example of what we want our final product to look like. Now, our next example is asking us to solve graphically, but this time it's an equal sign. So notice when it's an equal sign, we don't have any shading to do. All right, we're just going to graph it. So we're going to start with y equals -x minus 3. The -3 is our y-intercept, so we go down to -3. And then our slope is -x, so that's down 1 over 1. And we're just going to repeat that pattern all the way across our graph. Don't skip this step or cut corners, because that's when mistakes happen. So we connect all our points and then connect the dots with a hopefully straight line. All right, there we go. So our first line should look like that. Now I want to double check. I see a negative coefficient, so I should have a downward facing line, and I do. So my slope matches, and then I see my y-intercept is a -3, and I'm crossing the y-axis at -3. So I've correctly graphed this equation. Now we're going to move on to the next one. Y equals 5/4 x plus 6. So our y-intercept, our starting point, is +6. And our slope is +5 over 4. So that's up 5 to the right 4. And if you might forget, draw your little arrows. Up 5 to the right 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Now we've run out of space, so go back to your starting point. And then our original slope was up 5 to the right 4. So we're going to go down 5 to the left 4. And then repeat. Down 5, 1, 2, 3, 4, 5. Left, 1, 2, 3, 4. Now we have enough points that we've stretched across our whole graph. So now we connect them, hopefully neatly. Hopefully a little neater than mine. That's what happens when you don't use a straight edge. And then we want to identify our solution. Now remember, when we're not working with a system of inequalities, our system of linear equations is going to have just one solution. Or it might be a special case that has no solutions or infinite solutions. But in this case, we have two lines that are intersecting at one point. So that one point is what we would call our solution. So that point is -4, 1. And that would be our final answer. Moving down and back to inequalities, so we're jumping around a little bit, just like your test might. So you never know what's going to come next. Now we're going over to inequalities. I know that because I see a graph with shading. When I see shading, I should be thinking, oh, must be an inequality. Shading equals inequality. Now, when we are being asked to write a system of equations, if they've given us a graph, we're going to basically do the opposite of what we were just doing. Instead of taking an equation and plotting each piece of the equation until we have a line, we're going to take a line and pull out each piece of the equation and write it down. So here's what I mean. Let's look at our first graph. This is our first system of inequalities. I'm going to start with this solid line. Now, if it's a solid line, I know it's going to be less than or equal to or greater than or equal to. I know I'm going to have a y just because I always do. Y equals mx plus b. And then I need to find my slope and my y-intercept. So this graph, or this line, crosses the y-axis at -1. So my y-intercept is -1. And then my slope, I want to count from one point to the next. Now I want to go towards the right so I get the proper slope. Before you even start counting, you should be able to decide if your slope is going to be negative or positive. Because I see this line going downward, I know my slope is going to be negative. Now what that slope is I need to count to figure it out. So I'm going to go down 1 over 1, 2. So my slope is -1 over 2x, and my y-intercept is -1. So now the only thing we have left to do is figure out which of these inequality signs to use. So we have to look and see what side is shaded. So if this is the line we're talking about, the side opposite of our origin point is the side that is shaded. So that means we want to pick the inequality sign that would be false if we were to plug it in to, or use it in our equation when we use the test point 0, 0. So let's say I chose less than or equal to. So if I plug that in, 0 is less than or equal to -1/2 x minus 1. So 0 is less than or equal to -1 because we replace this with a 0. And that's false. So we wanted false because we wanted to shade away from the origin point, which was our test point. So our equation is y, and we used this sign to make it a false statement, is less than or equal to -1/2 x minus 1. So that's our equation for the solid line. Now our dashed line is going to be either less than or greater than. Our y-intercept is -3, and our slope is positive up 1 over 2. So positive 1 over 2x minus 3. Now we just need to figure out the shading. So notice on this line, if we're looking at the dotted line, the shading is on this side of it. So that means it's on the same side as the origin point. So we want to find which sign makes our shading or our inequality true when we use the test point. So I'm going to plug in, let's start with the first one, less than. So 0 is less than 0 minus 3. 0 is less than -3. False. So I think we're going to want this sign. Let's test it. Y is greater than 1/2 x minus 3. 0 is greater than -3. That's true. So that's our second inequality for the system. So my answer is y is less than or equal to negative 1/2 x minus 1, and y is greater than 1/2 x minus 3. All right, let's try this next one. So here we have two solid line graphs. I see that my first graph has no slope. So that's going to be y is either greater than or less than 1, the point where it intersects. Now notice the shading for this graph is above the line. So that's representing all of the y values that would be greater than 1. So if I plug in my point, I think I'm going to want this sign, but let's test it. So if I plug in 0, which is right here, is greater than 1, that's false. And I did want to shade the opposite side. So that's my correct sign. Y is greater than 1. Now, let's do the second line. Again, it's solid, which actually makes me realize we forgot something that is very likely something you could forget on your quiz or test. If I were to go back and check this line, I'd want to check the slope. There is no slope, so I shouldn't have an x. I'd want to check the y-intercept, which here is 1, and my y-intercept in my equation is 1. And then I want to check my sign. Now my sign says y is greater than 1, which the shading represents that, yes, but the line is solid. So it should be y is greater than or equal to 1. Now I have another solid line, so again, I want less than or equal to or greater than or equal to. This time, my y-intercept is positive 3, and my slope is negative, because my line's going down, and it's down 1, 2, so negative 2 over 1, 2, 3. And because the 3 was positive, that's a plus 3. Now, I want to pick which sign to use. If I'm looking at my shading, everything to the right of my graph has been shaded. So I think we're going to want to use our greater than sign. Let's see. 0 is greater than or equal to 0 plus 3. That's false. And if that was the test point 0, 0, so with that being false, we would shade this side of the graph. So y is greater than or equal to negative 2/3 x plus 3. There is our second inequality. So this would be our system for the graph here. All right, that was a lot of graphing. So let's move away from the graphing and just review what you are already awesome at, which is substitution and elimination. Now, for this first one with substitution, I want to get y alone, and I see that I already have a y with no coefficient. So I'm going to get that y alone by adding 2x to both sides. Watch your inverse operations carefully. Keep the sign that's in front of the variable, but this is a positive or a plus sign, so we can just write y equals 2x minus 12. Now we can take that value for y and plug it into our equation. So 3x plus 7 times 2x minus 12 equals 1. From here we distribute. Make sure to distribute to your second term. That's a very common mistake. So we get 3x plus 14x, and then 7 times 12. That would give us 84, but it's a negative 12, so minus 84 equals 1. Now, when I combine like terms, I get 17x minus 84 equals 1. I'm going to add 84 to both sides. We get 17x equals 85. And then when I divide 85 divided by 17, we get x equals 5. Now that we know what x is, we're going to plug it into one of our equations. I'm going to use my second equation just because I haven't used it yet. So negative 2 times 5 plus y equals negative 12. So negative 10 plus y is negative 12. Let's add 10 to both sides to cancel that out on the left. And we get y equals negative 2. So our solution for this system would be 5, negative 2. Our next equation, we have x and y. I could get either of them alone. It does not have to be y that we start with. And in fact, if I were to move the x, I would be left with a negative y, and that would just give me one more step to do. So instead, I'm going to add y to both sides and get x equals y plus 2. So now I have a value that can be plugged in to our equation. So that would be negative 3 times y plus 2 plus 3y equals negative 6. So that's negative 3y minus 6 plus 3y equals negative 6. Now, here is where we often see wrong turns. At this point, you might already be noticing that we have negative 3y and positive 3y on the same side of the equals sign. We have to combine those like terms. And when this happens, a lot of us see this and think, oh, it's going to be 0 or it's going to be no solution. But we can't make that decision until we've solved it through. So we're going to actually combine these like terms, and we get 0 minus 6 equals negative 6. Then when we get rid of the 0, it's negative 6 equals negative 6. That's a true statement. So when you've gotten to the point that you don't have any more variables, but your statement is true, that is when your answer is all real numbers or infinite solutions. Next, solve the system by elimination. So this first one is set up nicely for us because you see we already have common coefficients, common variables, and opposite signs. So I'm already set up, so I'm just going to jump right into adding these two equations. When I do 6x minus 6x, I get 0. Negative 8y plus 8y is 0. And 8 minus 4 is 4. So now when I simplify this, I get 0 equals 4, which is a false statement. So this one is a no solution answer. Okay? And now our last elimination problem, if we look at our coefficients and our variables, nothing is set up to eliminate as it is. So we're going to have to multiply by something. When I look at my coefficients, the easiest thing to multiply by here would be 5 to turn this 2 into a 10, but then I'm going to still have negative 10 and negative 10, which won't cancel out. So I want to multiply by negative 5 so that I can flip the sign and change the coefficient. So this would become 40x plus 10y equals negative 60. Don't forget to distribute all all the way over to this side. And then this equation is still the same. Negative 6x minus 10y equals 26. So our y's can be eliminated. Those cancel out. 40 minus 6x is 34x equals negative 60 plus 26. So 60 minus 26 is 34, but we started with the negative number. That was the larger number, so negative 34. Now we divide by our coefficient. That gets x alone, and x equals negative 1. Now we take it, plug it into one of our equations. Negative 8 times negative 1 minus 2y equals 12. So that's positive 8 minus 2y equals 12. Subtract 8 from both sides. Negative 2y equals 4. We want y alone, so we divide by negative 2. And we get y equals negative 2. So our solution for this system is negative 1, negative 2. All right, last question. Let's wrap it up with a word problem. When you're given a word problem, read your directions carefully. This one wants us to write a system of equations and then find the solution. So let's read our problem. Ollie and Cooper are selling sweet treats for a school fundraiser. Customers can buy small boxes of chocolates and large boxes of cupcakes. Ollie sold 6 small boxes of chocolate. So let me just start writing down my info. This isn't going to be my equation, but I just want to make little notes. So Ollie equals 6 small boxes and 12 large boxes of cupcakes. 12 large. Then Cooper here, oh, and we can't skip over the total, $294. Now Cooper, he's our next seller. He sold 3 small boxes of chocolates and 2 large boxes of cupcakes. 3 small boxes, 2 large boxes. And his total was $79. So we want to find out what is the cost each of 1 small box and 1 large box. So let's start by setting up our equations. So this would be 6s plus 12b. I'm going to use b instead of l because that could look like a 1 and cause all sorts of mistakes. So 6 small boxes plus 12 big boxes equals $294. And then Cooper sold 3 small boxes plus 2 large boxes, and he made $79. Now, we can solve this any way we want. I personally see a great opportunity for elimination. So I'm going to multiply this equation by -2. That's going to turn this into 6s plus 12b equals 294. And then because I want to make my coefficient the same number but opposite sign, I'm going to multiply 3s by -2. And that's going to give me -6s, which will allow me to eliminate the s variable. But I have to remember, I have to distribute to all 3 terms. So this would be -6s minus 4b. And then we must still multiply 79 times 2. And we get -158 because it was -2. Now, when we add these equations together, the s's cancel out. So 12 big boxes minus 4 big boxes is 8 big boxes. And then 294 minus 158 is 136. So if we divide that by 8, 136 divided by 8 is going to tell us how much each big box costs, because this is saying 8 big boxes cost $136. So if we do 136 divided by the 8 boxes, we see the big boxes are $17. Now that we know what the big boxes cost, we can plug it into our equation to find the small box price. So 3S plus 2 big boxes equals $79. So 17 times 2 is 34. So 3S plus 34 equals 79. Let's subtract 34 to move it over to the other side with the constant and get our variable alone. So that becomes 3S equals 79 minus 34 is 45. Divide by 3, and the small box of chocolates cost $15. So our small box full of chocolate is 15, and our big box full of cupcakes is $17. All right, so I hope that this has been helpful. If you still have any questions, or if there was anything in this that you feel you want more help with, please come see me in the Math Center. Otherwise, good luck studying, and I will see you in class.